Okay, when I was finding those points of inflection before I messed something up, I'm not really sure what, but f double prime equals 0 at x equals negative 0.549 and x equals 1.215. So let's look at this on the curve. Negative 0.549. Now notice here's negative 1, so negative 0.549 is right about here. So right about there is one point of inflection. Notice we're going from concave up to concave down, or it's got its point of maximum steepness right there at that point. Now, the other place, 1.215, well, you can't really see this downhill slope the way it is right now. So let's get rid of this, and let's move our curve up. And let's zoom out just a little bit. Okay, so what we're looking for is the point of maximum steepness on the way down here. 3, 4, 5. Okay, so notice each block is 1 here, and 1.215 that's going to be located at 1.215 would be right about, let's see, yeah, make it about right there. That's the point of inflection on the way down. So notice it's concave downward to the left of that point, and it's concave upward to the right of that point. Now this is really difficult to tell just by eyeballing this function, but it's getting steeper and steeper till you get to right here, and then it starts to shallow out and get not as steep till it makes the minimum and then heads upward. So that's the key thing with, or I should say those are the key things of this section. Can you find your critical points by setting your first derivative equal to 0 and solving for x? Those are the locations of the critical points. Now to find the mins and maxes, you plug in your x value into the function, and that will give you the mins and maxes. Remember, your min and your maxes are y values. The x values are merely the location of those mins and maxes. Then, to confirm whether it's a min or a max, you can use the first derivative test, find out where the derivative changes from positive to negative, which means relative max, or negative to positive, which means relative min. The other way of finding out the mins and the maxes are finding where your second derivative is positive or negative at those critical points. So if second derivative is positive, concave up, you have a min. Second derivative negative, concave down, you have a max. Now, the other value of the second derivative is finding the points of inflection, or the change in concavity. And that's it for this section. Have fun with these.